Okay, so we are going to go over 5.5, ready, set, go, number 3. It says find BC. Now, with some of these diagrams, like the reason why they tell you to find certain ones is because like they ask you to find certain ones because it's going to help you actually find this one. So I'm going to label this diagram with all this information that's given to try to find BC. Yes. Okay. So it says the measure of angle CBD is 51 degrees. CBD. So that's 51 degrees in there. So I'm just going to write 51. Okay. And then it says 30 degrees is CDA. CDA. Okay. And I like seeing 30 degrees because that means it's my favorite triangle, my 3069 triangle. It says CAD is 90 degrees, which they've already labeled. And it says CA is 6 feet. CA is 6 feet. So I'm going to write 6 for this altitude here. So because they're asking you, oh no. So someone just asked, so wouldn't the 51 be up here? No. So whenever they're giving you angles, it's CBD, C, then B, then D. They're talking about this angle here, right? So the 51 goes with wherever the angle is, and this is matching up with the B being in the middle. So that's where it would go. Yeah. So then they're asking you to find, let's see, BC. Now notice here, this BC has no hat on it like I was drawing earlier. Oh no, that wasn't your class. That was another, sorry. So whenever it has no hat on it, that means we're talking about the length of that segment from C to A. So they want you to find BC, which is the length of segment BC. So they want you to find this X. So I'm going to label it as X. And then if you're used to looking at this triangle and seeing exactly what you need, do it. If you're not, I'm going to peel off this triangle over here and see if I can understand it a little bit better based on that information. So because I'm going to be working on number 3, I'm just going to scoot this over and put that same triangle right here. So I'm only going to draw this triangle here. So it's a right angle in there, letter A, letter B, letter C, and this is 51 degrees. And then while I'm doing that, can you see, did I forget anything? So I'm always going to ask, did I forget anything? Because number 1, that's just good practice to check your thing. Give me 1 second. Okay. So what we're going to do is look for, did I miss anything? Yes, someone said, oh, you missed the 6 feet, Miss Johnson. So I put the 6 feet right here. I put the 6 feet right here. And then I'm going to look for how I can find this hypotenuse or this X. Now, whenever you see a right triangle, I've been saying this over and over again, so hopefully you guys are all like, I get it, Miss Johnson. So there's 2 ways that your brain should go, either this or that, right? And so you should be saying, oh, yes, Miss Johnson, either the Pythagorean theorem or trig. So looking at this information, what I've given you here, which way are you going to go? Are you going to go Pythagorean theorem or are you going to do trig? Yeah, we'd have to do trig. So in case you don't know, the reason why we can't use Pythagorean theorem, in order to use the Pythagorean theorem, I need to have 3 sides of a right triangle, and 2 of those sides need to be known. Otherwise, I'm going to have 1 equation with 2 unknowns, and that doesn't help me. Okay, since I'm going to use trig, I want you to go through your so, ka, toa to decide which one would be best for this diagram. Would it be so? Would it be ka? Or would it be toa? So, ka, or toa? Yeah, so someone said in the chat, they said sine, Miss Johnson. Okay. So go ahead and write your equation that has sine in it. So I'm going to write sine. So you guys are going to write it. Some of my students call this sin. They're like, "Oh, Miss Johnson, sin." And I'm like, "No. It's actually sine. It's actually spelled sine, like SINE. But shorthand, we just write SIN. Just like COS is cosine, but we shorten it by saying COS. And tangent is really tangent, right? It's an actual, like, it's a word. It's not sin. All right. So did you guys write your equations? Very good. So what is the equation that I should write? Very good. Someone said sine of 51 degrees equals to 6 over x. That's perfect. So perfect, done. And then now you would just solve it. So go ahead and solve this equation. And then we'll meet back up and we'll make sure that you got the right answer. Actually plug it into your calculator as well, so that you guys can do that as well. I'll pull over my calculator. Okay. All right, so when we're solving this equation, the first thing that I do is I'm actually going to do these steps at the same exact time. I'm going to multiply by x and divide by sine 51. I'm going to multiply by x, and then I'm going to divide by sine 51. And some of you are like, Ms. Johnson, you could do that at the same time. Yes, you can multiply and divide at the same time, as well as add and subtract, as long as they're in the same step, right? Right. So, and that this bar should be all the way over like that. So notice the signs cancel on this side, and I'm left with x. The x's divide out, so I'm left with 6 over sine 51 degrees. And so I'm now going to plug this into my calculator. And the very first thing I should do, anybody know what the very first thing I should do before even typing this in? Yes, very good. I should check to make sure that this is in degrees, which it's not. Desmos has it set up for radians, and the reason why is because it's actually easier to work in radians than degrees. So my answer is 7.72 feet. 7.72 feet. And if you're wondering how I got the units of feet, is because remember 6 is 6 feet. If I take the sign of a number, it's just the number. It doesn't have any units attached to it, right? So then it's 6 feet divided by a regular number means it's feet. So my answer is about 7.72 feet. Okay, so that is about 7.72 feet. Is that okay? Okay, so with that being said, things that you should be a little bit more comfortable with is try to get comfortable with looking at these two diagrams and only focusing on the side that you're looking at. So if you need to peel it off, do so. But get your eyes comfortable with seeing this as a right triangle and doing the same exact work here. Like I could take all this work here and put it right here, because that's all I did was I was focused on this triangle. Okay, so the other thing that you should also be comfortable with is once you have a right triangle, I should check the two things, trig or Pythagorean theorem. And then once you've decided, oh, I want to use trig, or I have to use trig, then using sine, cosine, and tangent with precision, right? Like I'm not like trying sine, trying cosine, and trying tangent. So from here, it's this guy's opposite and hypotenuse. Oh, that's sine. So that I have to use sine kind of thing. All right. Thanks for listening.